Hello, hello. I'm going to make this classic because I like that way. I am here today to talk to you about Chapter 3, Lesson 4. This is talking about the distributive property, which does relate back to that hamburger ordering situation with 2 Cokes and a Coke and 3 Cokes and a small Coke and another small Coke, please. So, talking about the distributive property, it allows the number on the outside of the parentheses to be multiplied by each term on the inside of the parentheses. So, what happens, taking a little look here at a couple of examples, is whenever you have a number right next to a parenthesis, there's no addition sign there, there's no subtraction sign there, it's just number parenthesis. That tells you that you're going to take that number and multiply it by each term. So 3 times 2, and then you're going to add it to 3 times 7. Whoops, 3. I can do this. I know, they're used to this. 3 times 7. That is the distributive property. Kind of like if 3 was a plate of cookies, I'm going to give one to here, and I'm going to give a cookie to here. You hand them out to each kid. This is what it looks like, and you can solve from there. When you have a variable, it looks like this. Again, there's a number right next to a parenthesis, no operation signs between it, number parenthesis. So you're going to multiply 3 times x, which just looks like this, or honestly, I would prefer it to be this. And then you're going to take the 3 and multiply it by the 7. 3 times 7. So you will have 3x plus 3 times 7, which you can just write as 21. You can do this 3 times 7 in your head. You don't have to write this. You can just go straight to this 3x plus 21. So that's what it looks like. We always use the arrows to show what you're going to multiply. It's a good visual reminder of what you're doing. It's really helpful, and you might have been taught it in the past, when you want to multiply something large. 7 times 84, okay, it would be hard for me to do in my head. And I would be like, 7 times 4 is 28, put down the 8, carry the 2. But if you break it up into 80 plus 4, then you can have 7 times 80, which is easy, right? That's 560, plus 7 times 4, which is 28. And then 560 plus 28 is easier to do in your head. So 560 plus 30 maybe, minus 2. It's just easier to break it out that way instead of in your brain trying to figure out, sorry, I'm coughing, trying to figure out carrying and all that stuff. So 60, 70, 80, 90 minus 2. This is 588. All right. Now back to that ordering of the cheeseburgers and the small Cokes and the large Cokes and 2 small Cokes. If you had 4 people all ordering, okay, in a certain family, 4 or friends or whatever, they all order the same thing. They all order a drink, 2 cheeseburgers, and an ice cream. Really, really healthy, by the way. Instead of lining them all up and saying a drink plus a cheeseburger plus a cheeseburger plus an ice cream plus a drink plus a cheeseburger plus a cheeseburger plus an ice cream, if they all order the same thing, you can take that order and multiply by 4. So you're going to have 4 drinks plus, if each person gets 2 cheeseburgers, right? What's this be? 2 B's. 4 times 2, that's 8 burgers, plus 4 times 1 ice cream, 4 ice creams. That's what it would look like if you were distributing. And then you can just say, when you order, I'd like 4 small Cokes, 8 burgers, and 4 ice creams, instead of drink, 2 burgers, ice cream, drink, 2 burgers, ice cream. Another way to think about this is using an area model, which I just heard your collective groan from elementary school. However, it makes it super easy. You're going to take the number that's on the outside, put it on the side of your rectangle, and then take what's inside and split it up, 3x plus 2, okay? And then you just multiply like the multiplication fact chart. 5 times 3 is 15x plus 5 times 2 is 10. So that's another easy way to think of it. And if you don't like these arrow things, this is 15x plus 10. I really like the area model. It makes it really easy, and you can easily just make a quick box and do that, especially as things get more complicated. I think this particular problem is kind of more simple, but once we start adding more variables and longer terms, it might become easier to use the area model. So let's see if this really works. The old way we know is order of operations, where you do, what's the term you guys use? Multiply, divide, add, subtract, PEMDAS, parentheses, exponents, multiply, divide, add, subtract, okay? So you do typically what's in parentheses first. So 3 plus 6 is 9. You keep that in parentheses. There's no exponents, and now we're going to multiply. So 2 times 9 is 18. That's how you normally do it. And if you have all numbers, that's great. The problem comes when maybe one of these is an x instead of a number, where you can't solve it. But I want to prove to you that this distributive property works. You'll still get 18. So I'm going to do in my head 2 times 3 is 6. Add it to 2 times 6 is 12. And 6 plus 12 is 18. So what I wanted to show you there is that this idea of distributing is mathematically correct. And remember, I always show you with something simple, and you're sitting there like, duh, it's 18. Why is she doing that? But I'm showing you that the method, although the method I used is different here than here, you get the same answer. So I'm proving to you that the distributive property is a valid way to use mathematics. And the reason we need it is for examples like example 1, where we have an unknown, x. So we're going to distribute 6 times 2 is 12 plus 6 times 4x. 6 times 4 is 24 with the x. And then we're done. Remember that simplify means no like terms. Are either of these like terms? No, they don't both have an x, and no parentheses. So I'm done. That is simplified. It is an expression because there's no equal sign, and I can't get an answer until someone tells me what x is. All right. Let's go to example 2. Do not be thrown off if you have a fraction right next to the parentheses. Again, notice it's a number right next to the parenthesis. There's no operation. It's not 1/2 plus or 1/2 minus. It's just 1/2 parenthesis. That is your clue that you're going to distribute. Half of -6 is -3. That has an x with it. Plus half of 4 is 2. Notice I said of. Of is a keyword to multiply, and we typically use that when we're taking half of something. Are you going to eat half of that pizza? You ate half the cookies. Okay, of is that keyword to multiply. All right, so see if you can give this a shot here. hopefully, you can always pause it, but hopefully you got 4x plus 28 here. That is a simplified expression. There's no parentheses and there's no like terms. The example 4, you can pause and try on your own if you want. This is an example that is not simplified because it has parentheses. So I have to get rid of the parentheses using the distributive property. That's 15x. Remember, we're taking the sign in front of it. So we're looking at this 2 as a negative 2. 5 times negative 2 is negative 10. So you have 15x minus 10. I want to take a minute to tell you why. If we had 15x, well, this one would work out the same. But if you ended up sometimes with minus a negative 10, this looks really messy in here with all these signs. And we know your high school teachers are not going to like that. So that's why we're starting to see that the sign in front of it goes with the number, and that is a negative 2. So those are your notes for lesson 4. And you now have some homework on the next page. Here are some little rules to remind you how to multiply with signed numbers. And have a great day.